One method for solving a system of equations is by graphing. When we graph a system of equations, we're going to graph each of the equations that we are given, and we are looking for the point at which they cross if they do in fact cross. For my first equation, I will start at -6 because my first equation is in slope-intercept form, and slope-intercept form tells me to start at the b value, which is -6. And I'll use my slope of -3/1 to go down 3 to the right 1. Or if I feel like I need more points than just 2, I can also use a slope of 3/-1 because it's equivalent to -3. So I could go up 3 units to the left 1, up 3 to the left 1, etc. So I can make as many points as I need, and then I'm going to connect the dots with hopefully a nice straight line. Easier to do when you're not on a tablet. Next, I'm going to graph 2x minus y equals 1, and I can choose to either use intercepts on this one, and to use intercepts, it's like the cover-up trick. I'm in fact going to turn this into slope-intercept form by subtracting the 2x from each side to give me -y equals -2x plus 1, and then dividing everything by -1 to give me my new equation of y equals 2x minus 1. So I'm going to start at -1 on the y. I'm going to use my slope of 2/1 to go up 2 to the right 1 as many times as I would like. Or if I needed to go down, that would be down 2 into the left 1. And so we can see that these two lines do in fact cross, and the point at which they cross is at the coordinates -1, -3. That is the solution to my system because that is the point that I could plug into both equations and make them true. So that's the point at which they cross, which is the solution. For my next graph, I'm going to graph x equals 4. Remember, when you have only one variable, your line will either be vertical or horizontal. For an x equals 4, I'm going to go on the x-axis to 4 and put a point, and I'm going to draw a line that is perpendicular to the x-axis, which looks like this. Now I'm going to graph 3x minus 2y equals 6. I'm going to choose to use the cover-up trick on this one. So I'm going to cover up the 3x, which gives me -2y equals 6. So y must be -3. So I'm going to plot -3 on the x-axis. Remember, mathematically what I'm doing is I'm plugging in a 0 for x to find out when x is 0, what is y. And I find by doing the math that y would be -3, so the point 0, -3 is what I just plotted. Now I'm going to cover up the -2y, which is essentially me plugging in a 0 for y, which gives me 3x equals 6, which means x is 2. I'm then going to connect the dots and find where the two meet. And in this case, they look to meet at 4, 3. If you're not sure you did it correctly, then you can plug the 4 and the 3 back into either equation. I know that x equals 4 works because x is in fact 4, but if I'm not sure it worked on the second one, I would take 3 times 4 minus 2 times 3 and make sure that it does in fact equal 6. So this would be 12 minus 6, which is 6. So I know that that point is in fact on both lines. For this next example, y equals -4 would be the horizontal line going through the y-axis at -4. Just pretend that's a nice straight line for me. For my second one, I'm going to start at -8. I'm going to use my slope of 2 to go up 2/1, up 2/1, and find where the two lines cross. And if my first line would have been a bit straighter, then they would have crossed at 2, -4. So that would be my solution. For my next example, I would start at -2 on the y-axis because this is slope-intercept form. My slope is 1/2, so that's up 1/2. Remember, rise over run as many times as you need to. connect the dots. And for my second one, this is standard form. In standard form, I tend to use the cover-up trick, assuming I get nice whole numbers. So if I cover up the negative 2x, I get 4y equals 8, so y is 2. And if I cover up the 4y, I get negative 2x equals 8, so x is negative 4. When I graph these, I see that the two lines are parallel and will never cross each other. So when the two lines are parallel and don't cross, we call this no solution. For this example, the first one is in slope-intercept form, so I will start at positive 2. I will use my slope of negative 1/4 to go down 1 to the right 4 as many times as I need to, and connect the dots. For my second equation, I can use the cover-up trick. So I would cover up the x and get 4y equals 8, so y is 2, which is already right there. And I would then cover up 4y to get x equals 8. And so I can see that this would be the exact same line that I graphed the first time, even though they are in different forms. This is an infinitely many solutions question. And if they ask you what those solutions are, it would be any point that fell on either one of these lines. So I would say all of the x's such that, oh sorry, that's not true. I would say all of the x's and y's such that x and y belong to x plus 4y equals 8, or the other equation. I wanted to do one like this with you because they look a little bit different. Remember, this is just function notation, so this is the same as me saying y equals 3, which means go to the y value of 3 and draw a nice horizontal line, hopefully straighter than mine. And again, this is like y equals 2x plus 1, so I would start at plus 1 and go up 2 over 1 as many times as I needed to, and then connect the dots. And this point where they cross is 1, 3. Remember, we're always looking for the solution, so don't just stop when you are finished with graphing. Go ahead and try this one on your own, then press play to see how you did. For my first equation, I would start by using the cover-up trick because it is in standard form. I would cover up the minus x to get 3y equals negative 6, so y must be negative 2. Then I would cover up the 3y to get negative x equals negative 6, which means x must be positive 6. I would then connect the dots. My second equation is not in slope-intercept form and is not in standard form. So for this one, I would simply divide everything by 6 to turn it into slope-intercept form, and I would graph the resulting equation to start at positive 1 and use my slope of 1/3 to go up 1 over 3, up 1 over 3, as many times as I needed to. I would then connect the dots, and as we can see, these two lines will never cross, so this is a no solution.